Share. All right, so good afternoon, everyone, or at least those of us on the East Coast. Good morning to the rest of you all. Today, we are here to present our final innovation award winner. So today we have a presentation from James Horst on decarbonization of domestic hot water heaters, a lab he created. So before we get started, I want to give a little plug for CREATE. So createenergy.org. We have lots of resources and upcoming events. You can access our upcoming events by clicking here under events. We also have lots of educator resources and teacher resources available here. And on our YouTube page, we will also have a recording of this webinar after it's over. So I believe James is going to share some resources and labs that you may want to use in your classroom. So we're having a little technical activity, a little technical problems today, but hopefully we'll get through that. So some upcoming events we have this summer, we have several solar workshops in Wisconsin and North Carolina, and I believe they're all full right now, but I think North Carolina can accept a couple more participants if you want. And the Wisconsin workshops, I believe there's a wait list, but some people have been backing out. So we've been able to take some people off the wait list. So if you're interested in attending any of those, you can click under the events tab and you'll see those workshops. Next Monday, we're going to have our final faculty coffee hour on recruitment. This is going to be at noon Pacific time, 3 p.m. Eastern time, and all the other times in between. This is an informal opportunity for faculty to discuss issues and things that are going on at your school. So we always see that recruitment is a challenge for many of us. So if you're able to attend, please email Gabby. And again, you can always see upcoming events at the CREATE website under the events tab. So I have the opportunity to introduce our speaker today. So I have worked with James Horst for as long as you've been here at Delaware Tech. James has a lot of letters after his name, and I had to look them up. So he is a professional engineer. He holds a accredited professional in the LEED certification. He's a certified energy manager. He's a commissioning authority and a green building engineer. James, or Jim, is an instructor in the energy department at Delaware Technical Community College. Prior to joining the Del Tech team, he worked in the engineering field for a number of years. He has his professional engineering licenses in multiple states. He has a bachelor's degree in mechanical engineering from Penn State and a bachelor's degree in electrical engineering and a master's degree in manufacturing systems engineering from Lehigh University. Throughout his career, James has been chief engineer on many interesting domestic and offshore projects. He has designed and constructed a number of green buildings and presently lives in a net zero house that has been energy neutral for over 12 years. Jim embraces decarbonization and has owned several electric vehicles. I think he's on number 3 right now for the past almost 5 years. Yeah. Jim is also a certified energy manager and has a large number of past and present energy projects designed to save energy. So I want to welcome Jim, but give us a second. We're on the same computer here. So just give us 1 second to switch over. Are we still sharing?
No.
Okay, sorry. Great. All right. So
Now you are.
Well, thank you, Dr. Clemens, for the great introduction. Today, we're going to be talking about decarbonization for domestic water generation, or basically how we make hot water in our homes and in our houses. Okay. we go. Little slight technical difficulties here with a different machine. Anyway, carbon emissions. I'm sure everybody's pretty much understands that we have a large number of record storms coming around. The U.S. has been a top producer of carbon emissions, and emissions from fossil fuels are continuing to rise. So we teach that in our classes, and when one of the number one questions a lot of the students kind of ask is, well, they kind of understand the connection, but what can they do? So ways of decarbonization is what we're really going to talk about. I developed this lab that kind of like walks through different ways we generate pretty much hot water in our homes, and that'd be our focus of the day. I don't have time to go through all the lab itself. I'm going to just basically talk about the highlights and what I found, how this lab performs in the classroom. So 3 of the major items that you're using for generating hot water, usually in our homes, is natural gas, electricity, resistive type, or new basically out there in the industry for the last couple of years is using a heat pump version. Unfortunately, or basically fortunately, in the past, natural gas was always the lowest to operate, so it was essentially the one that was chosen. Not necessarily the lowest in the carbon emissions, but essentially the lowest because of the operating costs. And electric was higher. So if you actually had gas on the site or in your house or in the development, you always connected in and made your hot water through natural gas. But we're going to look at that a little bit differently on what is the impact on natural gas or using natural gas as a hot water generator in the carbon emissions. So, and that's what basically we're going to look at a little behind or a little above that, beyond that point. So our goal is really in this lab I generated to calculate the amount of carbon that's produced in different methods, then go a overview or basically see what the efficiencies of those methods are and estimate the carbon on an average household. First part is the fossil fuel. So pretty much took an easy way out here and got a camping stove and put basically a beaker of water on top of it and heated it up. I found that the first time going through, this was a little not that safe because, the student could spill the water. They have an open flame. We have a number of other things. So you can see on the right, we went into and got a compact backpacker type stove, which is all concealed tight. And the vessel on the top holds the water. It's insulated. And it's also used on a propane source that's readily available. So that worked out much better. First thing we got to do, though, is we got to make sure that we know how much fuel is inside that vessel before we start. And this seems to be the part that the student usually forgets. They used to go through the lab and then they find out, oh, we should have weighed the propane before we started. Because we're really looking at the heating value, basically how many BTUs per pound of propane used. So we need to know the difference in amount. And we're really basing the whole lab on, and the crust is the whole lab, it's just a definition of BTU. BTU is essentially the amount of energy it takes to raise water 1 degree Fahrenheit, 1 pound of water, 1 degree Fahrenheit. So the big point of the lab is also going back and thinking, hey, if the process is more efficient, we're going to use less fuel. We use less fuel, we have less carbon emissions. So the big part of it going through there and looking at the efficiency. So that's the second part. And what amazes most of the students after you find out going through this process on the first part of the lab is that their carbon footprint is 2 or 3 times or 4 times their own body weight in a year. And they can really see the impact there. And some of the questions that we go through, the lab has these questions in there. I won't go down in detail, but they're available when you look at the lab. That's I guess it's attachment. So the second way is going into doing the electric resistance and the source of electricity. Not too complicated. It's been out there a number of years. What we do in the lab, though, is we take a standard aquarium hot water heater. and basically put it in water, a known volume of water. We measure the quantity of energy going in, electricity going in, and we say, hey, most students say, well, that must be 100% efficient. We got same BTUs out as what's going in. Well, is it really that efficient? Because we aren't calculating how much losses in the electrical line and generation of carbon is actually back at the power plant. So main thing is using the data loggers and making sure they're in zero. That's one of the tips that seems to be a failure and most of the students do, is that they forget to zero out things and then they get the wrong numbers. So how do we figure out the carbon impact, or basically on electricity that doesn't really have any fossil fuel burning at the source, or at the, not the source, but in the lab? We have to go back and look at the carbon intensity. And that's how many pounds of carbon we produce after 1 kWh of energy. So we use the Sense app, which has, you can see there on the right, in the areas that we're at, it gives you a day-to-day or average over a week or a month, whichever you use, on what the carbon impact is on your utility that you're using for the lab. So in this case here, we have impact of only 0.34 or 32 pounds per kWh, but that can vary throughout the day and vary out time. So we use actual data to the day that we're using the lab. And we find out after doing all that, essentially most of the time, is that the fossil fuel footprint on the electric is actually bigger than the fossil fuel footprint. And that is mainly because of the carbon impact on the utility. If you have a utility that has a lot of carbon-based generation, not nuclear or renewable energy, solar and hydro, that will be most likely the outcome. And students kind of see that in the areas of where they are, that makes a big difference. So the third part is really the part that really was triggering in this whole demonstration or whole lab, and that is using a heat pump as the source of hot water. So we started out with, and I got one off the line of internet, basically a chiller for aquarium that, okay, I can use that. Uses a process of making, heat and cool water. However, when I was doing the work, I found out that there was a big issue because the heat pump I picked, or the device I picked, wasn't really a refrigeration unit. It was a solid state generation. So the efficiencies were very poor. So I replaced that with a you can see there it has an actual refrigeration or a compressor, and using that as a heat pump cycle. And now my COPs have dropped up, or went up basically 2.5 to 3. And now the emissions are about half of what the carbon emissions are for the other parts of the lab. So it gets good results. And that's really the result I was trying to get across to the students, that they do have a choice on what they have, on how they make their hot water, in affecting the carbon output in the emissions. So the hands-on experience to generate the hot water in the business and homes, and the direct impact for carbon emissions in production. So I'm pretty much the conclusion. If you have any questions?
It's Gabby here, James. I have a question for you. So how common are heat pump hot water heaters?
I couldn't hear you. What?
How common are heat pump hot water heaters? And this is just because I don't actually know that.
Well, they're getting to be much more popular. There's a lot more mixed brands out there available. Unfortunately, if you're not a wise consumer, most likely you will not have one, just because the installers and the area sellers and whatever kind of push the standard, either fossil fuel or electric resistance type heaters out there, but they are available at the local box stores. They do save a lot of carbon emissions, like we see in there. And I tell the students that not only are you doing that, you actually are going to save energy because they are efficient. So you get a win both ways.
James, I'll chime in, and you nailed it. So I do have a heat pump water heater, and when I got it because I knew I wanted it, and two people at the store tried to talk me out of it when I went to purchase it because it was just this unknown thing to them, and they were more confused about what it was. So if I hadn't been informed, they would have gladly pointed me right back to a traditional water heater. So yeah, you nailed it.
Yes, and that's the sad thing about it. And that's why I told you I put together this lab, because most consumers are not aware of there is an alternative source out there, and it actually does a lot for you, not only for the environment, but also for the basic indoor environment for your house, because it's actually acts like a dehumidifier also. So there's a lot of pluses. In fact, if you have resistive electric heat, hot water generation right now, and the unit's up in its age, I would replace it before it fails with one of these, with a heat pump unit.
Even with more than twice the cost, the savings on electrical consumption, I think the payback time I had calculated out was like just over 3.5 years. And I have had it for 5 years now. So, it has more than paid for itself in that short period of time. So yeah, it's the sticker shock situation, but totally agree that it's a total worthwhile investment.
Oh, yes, yes. And you're always hope your hot water heater lasts more than 2 or 3 years. So it's a no-brainer basically on they should almost outlaw the electric resistance units.
Andy, you answered my question before I could ask it. So Jim, what was the most challenging part of the lab? So for the students to calculate the carbon footprint or the carbon pounds, what was the most challenging calculation for them?
The most challenging was to get the heating value of the fuel and equate that into a quantity to get to a BTU. And on the carbon side, once they got the units correct, it's really a unit situation. It's not really a hard calculation, but they have to make sure they use the correct units. So they got to have the heating value of the fuel and the correct units, and then they have to measure, if they weigh the cylinder and they get it in ounces, they have to convert those ounces into pounds and that kind of thing. So it's really kind of a trace the units, watch, go be careful on the unit process. After that, they can come out with very good numbers, or very realistic numbers, that they can get a good grasp of.
What type of hot water heater was the easiest for the students?
Oh, the electric resistance one was the easiest one, because all the, now if you saw in the pictures there, let me go back here. If you saw in the pictures that I want to bring up, you see there, in that one, we have in a pretty good sized pitcher of water. Well, the aquarium pumps or the heaters aren't that powerful. They're only about 300 watts or so. And it takes a long time for that amount of water. So we really reduced it on previous labs to basically go into a little cylinder like that. It heat up the water a little faster just to make the process go faster. But essentially going with the same principle of how many BTUs we generate in our output over how much kW converted into BTUs as input.
So I know you wrote up this lab. Are you going to be able to share it with our community?
Yes, the
lab
lab is available. I don't know how we get it out there, but the lab is is free for the taking.
James, if you have materials, you can send them to me and I can post them on the Create website, or I can either post them on the Create website if they're 508 compliant, or if not, I can put a note and they can request them from me. So there's 2 ways that we can do that, so people have access if you're okay with that.
Sure, no
Okay.
problem. No, the more to use it, the better, you know, because I like to get the word out. I mean, I like to get this information out to other instructors to use because it's not a complicated lab view. Now, we need some equipment. I mean, the chiller is probably the most complicated or most costly item. But it really puts a point across that there is ways to save emissions in just your daily life.
That's
And if we
great.
have any more questions, we'll take them, but if not, Jim, if you'll stop sharing, I can share the lab on this. We switched computers and it didn't, a little backwards here, but I can share. I know he spent a lot of time on this, so I want to share this out, but we'll find a way to get it on the website as well. Are we seeing the lab report now?
It's the other Word document.
Am I sharing the wrong screen?
Yeah, that's this is the other Word document.
I can't use a left-handed mouse. And you can't use my right-handed mouse. But here you go. He did a really nice job writing up this lab report. And we tested it with a summer teacher workshop last summer. And you ran it with the Energy 101 or the physics classes. So we have some equipment, some calculations, talking about the different stations.
Yeah, that's great. And like I said, I would either, if it's 508 compliant, I can just post it directly to the Create website, or if not, I can make a note and they can request it and then I can email that directly to people.
Yeah.
But that's awesome.
Any other questions? Where else, Jim, could faculty or students find their carbon intensity? So you said you use the Sense app. Do you have any idea where you know Gabby could
I think
find?
that could be online if you go to the utility itself,
Okay.
whatever your local utility is, and look up their website. I think you can get that information there. The Sense app is very nice because it gives you a pretty easy right off your phone, you know, indication there. And I don't think you need I mean, the students can download that app free, so they can pick it up right there. They just have to put in the location where they're at and their local utility that provides the service. So it's a free app.
Okay, well, thank you all for attending live. When this recording is done, we'll get it posted on the website as well as with the lab, or you'll be able to access the lab through Gabby. So thank you all for attending. Have a great afternoon.
Thank you. And thanks, James.
Thank you.
Great.
So yeah, the problem is Jim has a left-handed mouse.